Me parece bien. Bueno, es una excelente conferencia que vamos a tener el día de hoy. Edgar va a ayudarnos ahorita con estos temas en inglés, en esa perfección de inglés que tiene Edgar. Cómo las técnicas de inteligencia artificial y aprendizaje automático pueden abordar la protección de datos y los desafíos de amenazas en el mundo actual. Está a cargo, como lo decía, a cargo de Krishna Narayanaswamy de Estados Unidos. Yo espero que lo haya pronunciado bien y si no, pues que me jalen las orejas, pero pues eso es un apellido bastante complejo para los que hablamos en español, pero creo que así es en la transliteración. Como había dicho, es fundador y CTO de Netskope, cuenta con 2 décadas de liderazgo y visión técnica, autor y speaker prolífico en una variedad de temas de seguridad en la nube, tiene más de 20 patentes, coautor del libro Cloud Security for Dummies. Edgar, pues para nosotros es un placer tenerlo aquí en Tactical Edge y abriendo este gran evento.
Sí, sí, sí. Krishna, thank you so much for being with us. Really appreciate it. To me, to us, it's an honor to have, the founder and CTO of Netskope. Wow, it's unprecedented. So thank you so much. Welcome to Tactical Edge. How do you like Maritza's pronunciation of your last name?
Gracias is very good. Actually, I've not seen anybody pronounce it that well. So thank you.
Muy bien, Maritza, te ganaste un punto. Ya estás en el líder de la plataforma. Well, Krishna, it would have been nice to have been able to welcome you physically in beautiful Colombia. But that's, hopefully 2021 is nicer to all of us. What is your presentation going to be about?
So my presentation is going to be about how do you solve security challenges using artificial intelligence and machine learning.
Excellent,
So
perfect.
I'm going to talk initially about what are the challenges before even we get to artificial intelligence and machine learning. What are the problems that the industry is facing? And then how do you solve those problems using newer techniques like artificial intelligence and machine learning?
Excellent, excellent. Well, Krishna, welcome to Tactical Edge. The stage is all yours. Let me just give you, so you can go ahead and share your screen, and you're all set to go.
Welcome and glad to meet you.
Gracias, gracias. Let me share my screen.
Please.
Can you see my screen?
Yes, we can. Thank you so much, Krishna.
Turn off my video so that it doesn't interfere with the...
Perfect. Thank you.
Thank you. Hola, buenos dias. That's all I know about Spanish. I'm going to do this presentation in English. As we said, the topic today that we are going to discuss is how do we address data and threat protection challenges using artificial intelligence and machine learning. And before we get into the actual artificial intelligence and machine learning, let me explain what are the problems that the industry is facing today. So as you know, for the past 6 months, all our lives have been changed in a very dramatic way. As of now, remote work is becoming more and more common. What we are observing in our cloud is compared to 6 months ago, the number of people using all services remote is very high. Right now, it's around 64%. It used to be around 20% of the traffic that we see were originating from remote workers, but now it's more like 64%, and it's probably going to stay that way for a long time. Now, what that does is it increases the risk associated with data of corporations. And what we've also found that IT departments, in order to be effective during this period of pandemic, they're embracing cloud applications. More and more applications are being used in the cloud, like SaaS applications, EAS applications, PaaS applications. And what that leads to is also increases the risk. And let's take a quick look at some of those risks. So when you start using the cloud, what happens is cloud is another way in which malware can be delivered to endpoints, right? And what we are finding is many organizations have adopted Office 365 or they have adopted Google Suite, right? Now, all of these applications, as you know, is also available to consumers like you and me. We can have our own accounts where we can store data. Now, when you have legacy security solutions like a secure web gateway, and you allow Office 365, it does not differentiate between, like, is this the company's instance of Office 365 or a personal instance? So what we're finding is more and more of the bad actors, the hackers and the organized crime, what they're using cloud applications to deliver malware. So the top 5 applications from where we are seeing malware coming is OneDrive, SharePoint. Both of these are from Office 365 box, Google Drive, and S3, Amazon S3. So as you know, Amazon, Azure, and GCP are the most common public cloud platforms, and hackers are abusing those platforms to deliver malware. The next thing, so that is threats coming from the outside. Now, what about insiders? There are many ways in which insiders have tried to take data out. And currently what we are observing is, instead of using USB drives, many companies try to block USB drives or encrypt USB drives and so on. But instead of using those USB drives or printing, what we're finding insiders do is they're again using the cloud. They're uploading files to OneDrive or to Google Drive. So the top 5 applications that we see where personal instances, that is not the company's instance, but somebody's personal instance being used, is OneDrive, Google Drive, Gmail, Box, and Dropbox. So what this means is, as we go remote and as we start embracing cloud applications, we have to be aware that these are the ways in which threats can come in, and these are the ways also in which data can be exfiltrated out. So overall, if you look at the cyber terrain map, right, probably if you go back and look at what you're doing, you're probably covering web very well using secure web gateway. You have email, like email security solutions that look for phishing, spam, and so on. And also on the network side, you probably have a firewall, next-gen firewall. And on endpoints, you have some form of antivirus, or you're using EDR. You have vendors like CrowdStrike, Carbon Black, SentinelOne, and so on, right? But what you have to start looking at is this new vector called the cloud. And when you look at cloud, you also have to be aware that as IT department, you may know about some managed applications, but what we are finding is there's a lot of unmanaged applications. This is called shadow IT, right? Many organizations, individual groups like finance group, HR group, or marketing group, they go and acquire cloud applications without the security knowing about it. So those are unmanaged apps. Of course, you have custom apps. These are apps that you are running in your own data centers or in the public cloud, right? So all of this becomes important to consider when you're looking at the overall picture of your cybersecurity terrain. And a few things to note based on our experience, right? The average number of apps for a small organization is around 500, and it keeps going up. For a large or extra large organization, the number of cloud applications that we are finding, so these are SaaS applications, EAS applications, and PaaS applications, is in the thousands, right? And all these applications are not created equal. Some of them are more risky. Like, for example, if you upload data to some cloud storage applications, the terms and conditions say that they own the data. So you got to be very careful where your users are putting the data, because in some cases, the data may escape from your control. Similarly, as I said earlier, we are also seeing more and more cloud-enabled threats. Phishing is coming through the cloud, so people are using OneDrive links, Google Drive links, Box links to deliver phishing messages, right? So when you look at the link, it says Box or it says OneDrive, but you should not trust it because it may not be your company's Box instance. It could be the hacker's Box instance or OneDrive instance. So delivering threats through cloud is becoming more and more common. And so what we are finding is 60% of the threats that we are detecting is on the cloud apps and not on web. As I said, many organizations have covered web very well, but today the trend is that attacks are not coming through the web, but they're more so coming on the cloud, right? And the reason they do that is most of the cloud domains are trusted domains like drive.google.com or portal.office.com or all those, or portal.azure.com. Those are all like trusted domains, but then those domains are the ones from which you're getting your phishing emails and people are uploading sensitive data. So I want to frame that because it's a very, very important aspect of how you modernize your security. So overall, based on the trends that we are observing, what we need to do as security professionals in order to be more modern is we want to make sure that your security policies are risk-based and data-centric, right? Do not say that, oh, I have a secure web gateway, I have email protection. That's not enough. I think you need to look at the security from three places: users, apps, and data, right? And so with users can be working from anywhere. So how do you protect them, right? You want to have direct internet access, especially in these days when the majority of your workforce is working remote. You do not want them to open VPN so that they can come back to on-premises where you can run it through your secure web gateway, your next-gen firewall, and so on. What that does is it makes it very, very inefficient. The user experience of users using the cloud becomes very poor. So what you want to do is you want direct internet access. And when you do that, you also want to apply granular controls, which I'm going to talk about, and consolidate and modernize your security. And that is where the rest of the talk, I'm going to talk about how you can modernize your security. So overall, when you look at your security program, especially from a network security point of view, where users can be working from anywhere, they can be in offices, they can be at home, they can be in the park or in a coffee shop, and they're accessing SaaS applications, IaaS applications, web, or the internet, or even your private applications in your data center. You want them to efficiently deliver the security in the cloud. So that's what we call the security cloud. And the security services that you see in a good security cloud are CASB, Cloud Access Security Broker, Cloud DLP, Threat Protection, CSPM, which stands for Posture Management, and then the Next Gen Secure Web Gateway, which is for access to all the internet, right? Overall, these are the services that you want to deliver in the cloud. You do not want your users to no longer come to your data center to deliver these services. Now, as you do these services, you also want to integrate with identity, right? Important aspects are like single sign-on. More and more organizations, as they adopt the cloud, are also adopting single sign-on solutions like Okta, Ping, and so on, right? And or even Azure AD. Similarly, user behavior. How do you integrate user behavior, EDR, endpoint detection and response? All of this gets integrated into the cloud. And I will try to cover some of that in the rest of my talk. But overall, when you look at your network security and how you want to modernize it, you want to move it to the cloud and provide a set of services. In the future, the services will grow. Even the firewall, we predict, will come to the cloud. So overall, there should be no reason for your users to open a VPN and go back to your premises, except for maybe a few private applications that you still run in your data center. So this is the new way in which we are observing the industry moving, and more organizations adopting this blueprint for network security. So in the context of that, let's talk about how do you modernize your security controls, right? So when you look at a typical security solution, you will see many different techniques that are being used to address security. So you will hear about pattern matching, regular expression matching, static analysis, sandboxing, fingerprinting, and so on, right? So all of these are good, but as you know, right, threats are constantly evolving. Threats are not stopping. We still continue to see ransomware attacks. We still continue to see phishing attacks and data breaches, right? And there's more and more desire to cover these because you have many regulations like GDPR and so on, which want to protect the privacy of citizens, right? So what we have found is AI and ML, artificial intelligence and machine learning algorithms are very well suited to augment, to add to these techniques that we already have. So you would see these techniques in blue in many of the security solutions that you already have, like a next-gen firewall or a secure web gateway or an email security system or even an EDR. But where you want to take your security program, when you look at products and evaluate products, you want to see how much of artificial intelligence and machine learning they have incorporated to address security. Because, as I said, threats are evolving and you want to have a modern way of addressing those threats. So with that, what I'm going to do is I'm going to take different topics. I'm going to talk about data protection first, and then threat protection next, and see what are the problems in data protection and how artificial intelligence and machine learning can help protect us. So when we talk about data protection, the first thing that comes to mind is DLP, right? Data loss prevention. And if you look at anybody's DLP program today, it will have a bunch of things that they address. DLP is very good in email, removable media. People have DLP running on endpoints to make sure that USB drives are protected. People don't copy sensitive data, printing, web surfing, make sure that people are not uploading sensitive data. And then definitely on-prem file shares, like NFS, CIFS file share, and so on. All of those are very well protected. But as you heard from my previous slides, right, the way in which data is moving today is much more. The more common ways in which data is lost today is file sharing applications, things like Dropbox, Box, OneDrive, Google Drive, collaboration applications like Slack, Facebook for Workplace, Twitter, and LinkedIn, and so on, right? Those are the applications through which, and social media applications through which people are exfiltrating data, right? Similarly, corporate SaaS applications, as I said, there's a variety of SaaS applications that are not managed, shadow IT, public cloud storage, right? And then, of course, your personal email and other things that were here still continue to be vectors through which data can be lost. But what I want to emphasize here is the new set of vectors that you have to cover, and most of these vectors are sitting in the cloud, right? So as you look at your data loss prevention, I would highly recommend that you look at some of the more modern ways in which data is being exfiltrated out. So just to give you an example of that, right? What we are finding is many cases where in organizations that users are exfiltrating data through different instances of applications. So for example, let's talk about Google Drive, right? And this applies to Box or to OneDrive as well. If you look at the URL, it's drive.google.com. So your company may have your Google Drive. Your partners, obviously, if you're in business, you're working with some other partners. Your partners have their own Google Drive. That's also drive.google.com. And of course, you may have your own @gmail.com address, which is also drive.google.com. So if you have a security solution that is allowing or denying based on URL, which is what a secure web gateway does, you're going to allow all these three. Whereas in your particular security program, you may want to allow obviously you want to allow your company, you want to allow your partners access to Google Drive. But if somebody tries to upload to their personal instance, you want to block it, right? So you want to look at security solutions that can allow you to do that. Similarly, if somebody is coming from their own device, like bring your own device, like personal devices, and if Google Drive, if they go to your company's Google Drive, you want to allow them to view the content but not download it, because if they download the content, you lose the data. So overall, this is just one example. If as you start adopting cloud, you will find that there are more and more cases where instance awareness becomes very important, because many of the cloud applications have a personal instance and a corporate instance, and you cannot determine whether somebody is going to their personal instance or to the corporate instance just by looking at the URL. And I gave the example of Google Drive here, but this applies to OneDrive, to Box, to Dropbox, and so on. So overall, when you look at addressing these types of problems, what is very important is granular visibility, right? So what do I mean by granular visibility? When I say granular visibility, you want to know who the user is. And in many cases, most organizations use Active Directory for storing their users. So some way of identifying the user and what groups they belong to. Are they part of accounting department? Are they part of finance or HR, and so on, right? Then you also want to know what device they're coming from. Is this user coming from a managed device given by the corporation or from a personal device? Similarly, what app are they going to? Are they going to a collaboration app? Are they going to a storage app? Or are they going to a CRM app like Salesforce, right? And is that app a managed or unmanaged? What I mean by managed or unmanaged is managed apps are the ones that IT security knows about. They have admin controls. They can go and configure the application from a security point of view. Unmanaged apps are the apps that IT security does not know about. This is shadow IT. And so they cannot go and control those applications. Then you also want to know the instance. Is Pat here going to the company instance, or are they going to her personal instance? Similarly, as I said, there are many cloud applications. So we at Netskope have about 33,000 cloud applications, SaaS applications. All these applications are not created equally. Some of them are more risky. As I said earlier, if you upload your data, some applications say that they own the data, right? So obviously they're more risky. So you want to factor risk. We have something called CCI, which is Cloud Confidence Index. It's a risk rating from 0 to 100. 100 meaning application is good. So if you look at a Google Drive or a OneDrive, their score will be in the 90. But if you look at something like vTransfer, it'll be like 10 or 15 because it's a very poor app. So incorporating some risk rating into your security is also very important. Then when users are going to the web, you want to know what category of websites they're going to, because inherently some categories are more risky, right? And so you want to block those if they are going to very risky categories. And this becomes very important, right? The activity, what is the user trying to do? And this is something that many security solutions do not have, right? What is the activity that the user is performing? Are they uploading a file? Are they downloading? Are they sharing? Are they on a Slack channel posting some data? That becomes very important, because what action you take or policy you enforce depends on what activity somebody is doing, right? So that is very important. And then finally, you also want to do threat. You want to make sure that malware is not coming in, because users are using cloud applications or going to the internet. You do not want to have malware or ransomware come. So being able to identify threats is important. And then of course, what we are going to talk about, which is data protection, content. How do you know that the data is sensitive? Is this sensitive data or is this some benign data, right? So being able to classify the content is also important. And once you do that, you also want to take policy action. And policy action is not allow or block, but you also want the capability to coach your users, right? So for example, if somebody is trying to upload a file to Dropbox and Dropbox is not a sanctioned application, you can coach the user, right? So this is the concept of continuous education or training, where you're continuously telling the user you're performing an activity that is not permissive, please do use some other application. So that type of coaching is becoming more and more common, rather than send users to training on they should not be clicking on suspicious links. If you detect them doing something suspicious or something that is out of policy, right when they perform that activity, you coach them and tell them the activity that you're doing is not allowed by policy, so try doing something else, right? Try some other application. So that is very important. So let me give you some examples of this, right? So in this case, if Pat, the user, is on a desktop, which is in the office, and using personal MS Teams, right? She's going to her personal Microsoft Teams and uploading a file. You want to do a DLP check. If you're in the financial services, you want to make sure it's not PCI or PII data, right? You want to make sure that any company data is not being uploaded. But if Pat is uploading the football schedule for her kids, that is okay, because in these days people do work and home together at the same time. So it's perfectly all right to upload the football schedule for her kids. But if she's uploading PCI data, then you want to block it, right? Similarly, if Pat was going to the company's Teams instance, then you can allow her to upload any file, PCI file, because it's a company's Teams instance, right? But you may want to check if there's malware, right? Because what if Pat is a disgruntled employee and she's just trying to upload malware and then somebody else downloads and gets infected? So that is something that you can do using a very granular policy enforcement that I've shown here. Similarly, if Pat was using her mobile phone and going to the company's Teams instance, you want to make sure that she does not download files, because if she downloads files, that data will go away, right? So when users are using their own devices, give them read-only or view-only mode and do not allow them to download content. Similarly, if Pat is browsing from her desktop, browsing a gambling site, we know gambling sites are highly risky in terms of malware delivery. So you want to block it and then coach Pat with a message that says that on the work machine, you're not allowed to go to risky websites because you can get infected, right? So this is just a few examples, but this can be done for all types of applications: Slack, Outlook, OneDrive, SharePoint, and so on, right? So overall, when you start looking at security policy enforcement, the days where you were setting policies based on application, allow application, block application, is gone. Where people are taking their security policies is more fine-grained control, like what I'm showing here, where they can get better control of what the users are doing and reduce the risk. So here, security becomes an enabler. You are allowing your users to use the web, to use cloud, but then use it responsibly, such that your corporate's data is not put at risk. So that is very, very important aspect of a security policy enforcement that you should consider. Now, moving along, when you look at data protection, right, overall, as I said, many people, when we talk about data protection, think about DLP, right? But actually, you want to look at it one level higher than DLP. We call it this 360 degrees data protection. So what we mean by here is there are many policies that you can put without even looking at the content. For example, like I said before, if somebody is going to a very risky application, right, cloud storage application, you don't need to look at whether they're uploading PCI data or a football schedule. You can just block it because it's not safe, right? Or if somebody is trying to download data to their mobile phone, you can just block it because you don't want to do that. You don't want to allow any data from your application to be downloaded to their mobile device. So for all of this, you're not doing DLP, right? So first, use policies that do not have to look at the content. Now, once you have set all those policies, the next step when you come to the lower right here is where you want to open files. If somebody is uploading a file, you want to open the file. For example, the example I gave before, if Pat is uploading a file to her personal MS Teams and you want to make sure it's not PCI data, you want to open the file and look for sensitive data. And you can do that in many ways, right? These days, more and more organizations are using data classification systems. Like many of you may have adopted Office 365's AIP, Azure Information Protection. So AIP allows you to label documents. So what you can do is you can look at labels and then enforce policies. Now, if the file does not have labels, then you can start looking at the content of the file and see, is this PCI data? Is this health data? And classify the data. And that is a tough problem. And that is where artificial intelligence and machine learning can help. So let's look at that. So if you have data DLP system today, I'm sure you're very familiar with rules-based, regex, keyword, fingerprint matching, and so on, exact data matching, I'm sure. And even some of the modern DLP systems have optical character recognition. So all of this is kind of common. But where you want to look from a data classification point of view is how can I use machine learning to help with data classification? How can I use natural language processing? These are the more modern ways in which you can protect your data. So let's look at how that can be done. So before I get there, I just want to share with you statistics that we gathered in our cloud, in the Netskope Cloud, right? When overall on a per day, we are scanning over 100 million pieces of content. This could be files, this could be Slack posts, MS Team posts, and so on, right? And I did an analysis of what are the types of files that users are sharing, right? And the interesting thing is a vast majority of it, 34%, is plain text, right? So this could be like Slack post or Twitter post and things like that. 26% is images, right? I want you to fix on that, right? 26% are images. So these are JPEG files. This could be like GIF files, PNG files, right? These are pictures that are being uploaded, right? Similarly, other things which are common are, Word documents, spreadsheets, and so on. But overall, if you look at it, right, the majority of the content, over 90% of the content, are either images or some form of text content. So this could be plain text, it could be Word documents, Excel spreadsheets, and so on. So I want you to remember this, because what I'm going to share with you is dependent on this. So now let's look at images, right? What can DLP systems do for images, right? Images are very difficult, right? The only thing that I know that DLP systems allow you to do is OCR, which stands for optical character recognition. So with the optical character recognition, what you can do is you can take a picture and then you can try to extract the text out of the picture. Is there any text content? And you can do that, right? And many times OCR is not deterministic. It fails, right? Because many of the pictures have background images that kind of blur the text content. The only place where OCR is effective is when you scan pages. If you have a printed page and use a scanner, then OCR is good. But anytime you take a picture, so let's take some examples. Passports, right? In many places, people scan your passport as a form of identity check, right? So when you look at the passport, right, it's very difficult to look at the content of the passport because there's a lot of images in the back. And so what we have done here at Netskope is used artificial intelligence and machine learning to identify passport images from 55 countries, driver's licenses, national ID cards, and also pictures of credit cards, right? So here, what we'll be able to do is when we look at a picture, we can say it's a picture of a passport. We will not be able to say if it's Edgar's passport or Daniel's passport, but we will tell you that it's a picture of a passport. And by knowing it's a picture of a passport, and if the user is uploading it to their personal instance of MS Teams, or if they are uploading it to a risky cloud application, you can take an action to block. Now, the way we do that is when you look at machine learning, there are two common ways in which AI and machine learning is applied. One is called supervised machine learning, and another one is unsupervised machine learning. This is an example of supervised machine learning. With supervised machine learning, we pre-train. So we train the model. So we build a model using convolutional neural network, and we take a lot of data of passports. Let's take the example of passports. Take like thousands of images of passports, right? Feed it to the training machine, and then it builds out a model. That model says that when you give it a picture, it'll tell you, is this a passport, is this a driver's license, and so on. So this is called supervised machine learning. And what we have done is we have built models for passports, driver's licenses, national ID cards, credit cards, and so on, right? And so this is a very, very good example of how you can use machine learning to solve a data classification problem, which today, if you used OCR, you're probably going to miss majority of images, sensitive images that are being uploaded to locations where they should not be going. So that is IDs. Now, another common thing that people do these days is to take pictures of screenshots. Like I'm sitting on a machine, it's very easy for me to take a screenshot, right? On a Mac machine or on a Windows machine. And if you're using your company's laptop or desktop and you take a screenshot, the probability that that screen has sensitive data is very high. So what we have done, again, just like the passports and driver's licenses, we have trained a convolutional neural network to identify screenshots. We will not be able to tell you what is inside the screenshot, but we will be able to tell you that this JPEG image that is going to a personal Gmail is a screenshot. So if somebody is logged into their personal Gmail from their work laptop or desktop and they're uploading a screenshot, you can put a policy which says that any screenshots from a company device cannot be uploaded to personal email, right? So again, it helps you cover your risk because otherwise all these images, and going back to that data that I shared with you, 26% of files that are uploaded are images, JPEGs, PNGs, GIF files. So having some extra mechanisms or methods to detect sensitive data helps you in reducing your risk. So I've talked about like images. So let's move to documents, right? So many of the organizations, many businesses, right, have sensitive documents. This could be like NDA documents, some intellectual property, or it could be some business agreements, purchase orders, and so on, right? Today, the best way to detect the sensitive documents is to create keywords or to create regular expressions, right? And when you do that, you get a lot of false positives, right? And this is very common. One of the reasons why DLP failed. So DLP has been around since 2007, 2008, right? But if you ask anybody, I'm sure if I ask you, if I were there in front of you and asked to lift your hands, I'm sure I'll see many hands which say that, hey, I tried DLP and I see a lot of false positives. And this is where, again, AI and ML can help. So document classification using what is called NLP, natural language processing, is another set of algorithms that is part of the AI ML suite of algorithms, can be applied to documents to detect. So automatically you can detect sensitive documents. So you don't have to create regular expressions. You don't have to create keywords. Automatically, by having a model, you can detect, like in our case, in our cloud, we can detect resumes, patent documents, mergers and acquisition documents, tax documents, source code, for example, we can detect using this technique. So again, we are using the machine to automatically identify these documents and not have humans create keywords and regular expressions. So another great example of how artificial intelligence and machine learning can help here. Now, you may have the question, okay, I give you examples of like ID cards and some general documents that I have access to, that we as Netskope have access to. But what about your own data? In your own business, you may have very sensitive documents. So this is where the concept of train your own classifier comes in, right? So what you can do is, if you have your own set of data that you want to train a machine model, we provide a Docker container where we can process that data. And then what happens when you process the data is we extract some numbers out of them, right? And you can be assured that these numbers, we call them features, machine learning features, are irreversible, meaning that with these, I cannot go back to the images. It's a one-way transformation. You cannot go back. So you can be assured that your data is not leaking. But what we're doing is building a model, and then we take that model to the cloud so that subsequently, if your users are uploading any data that resembles this sensitive data, we can detect it and take policy action. So this is how we bring machine learning to you. So we build models in our cloud for our own, for the data that we have access to, like passports, driver's licenses, and so on. But for data that we don't have access to, which is very business critical for you, we have this concept of train your own classifier, where you can build your own classifier and so extend machine learning for your data. So it's a very, very interesting concept, and we are seeing a lot of interest in this, right? So this is all on data classification and data protection. So let's talk a little bit about insider threats. One of the other ways in which data gets exfiltrated is because of insiders. This is not hackers coming from outside, but this is more your own insiders, right? So as an insider, people are accessing and sending data to sanctioned applications like OneDrive, SharePoint, Google Drive. They may be going to unsanctioned applications like Box, Dropbox, and so on, to private applications in your own data center or in the public cloud like AWS, Azure. Or your users are also going to the internet, right? Like going to various websites, right? Now, as they send data to all these different clouds, one of the things that the best way to identify insider threats is to look at what kind of transactions are being performed and then correlating them for user behavior. How much ever you set policies for DLP, right? You use machine learning and all that. Sometimes very easy for users to evade that, right? And so the next best way in which you can detect users abusing your data is by doing what I call user behavior analytics. So this is where you want to profile your users. You want to see how users are behaving. And machine learning is very good for that, So as users are using these clouds, you gather data, and then you can apply machine learning models, right? Human beings are very predictable, and this is very commonly used even in the financial industry for detecting fraud, right? So users generally, when they use applications, they use it in a particular way. So if you start building machine learning models, so this is where this is unsupervised machine learning. The example I gave you before is supervised machine learning, where you provide data and train a model. But here, you're letting the machine automatically learn about users. Okay, this user, Edgar, goes to OneDrive. He usually does few uploads. He does a few downloads and so on, right? You let the machine learn how Edgar behaves. So all of a sudden, if you detect Edgar performing an activity that is not normal, then you know that that is an anomalous activity and you can take action. Now, you can do insider threats using machine learning and rule-based, but more and more strong cases for insider threats are detected using machine learning, because this is where you let the machine automatically learn about the user. You can also do peer group learning. So for example, you can see for accounting group or for HR group, what kind of applications you're using and what kind of data they're uploading, so that if you see something that is different, then you can raise an alert and take action. So examples of insider threats are things like data exfiltration, bulk upload, right? So or bulk download, like somebody leaving an organization can download all sensitive data and then upload it elsewhere, right? Or somebody who's not happy with the employer can go and delete a lot of files, which will hurt the business, right? All of this can be done using unsupervised machine learning, where the machine is automatically learning the behavior. Similarly, proximity. With cloud applications, it's very compromised credentials become very common, right? People lose their passwords, and then hackers are coming in. So you may see, normally you see users coming from Colombia, but all of a sudden, if you see users coming from the US or from Europe or Asia, you know that that is anomalous, right? And you may want to take some action. So this is where the machine automatically learns using unsupervised machine learning techniques and then detects anomalous behavior. Now, by doing so, one example is, this is something that happened in one of our customers. A contractor, when he was finished with his contract, he was a software contractor. He downloaded all the code he worked on from GitHub and then uploaded it to Dropbox. Now, here what happens is, we are observing both these activities. These activities happened at different times. He downloaded like a few hours before he uploaded, right? But you're able to correlate the two and say that this is anomalous behavior for this much data to be downloaded from GitHub, which is a sensitive application, and same data being uploaded to Dropbox. So this is a data exfiltration, and so you can take some action. And by using machine learning and observing this behavior, you can also start building a risk rating for users. Because in a large organization, there's always going to be some users who are more risky compared to other users, right? So the concept of a user confidence index, how confident are you about this user behaving regularly, right? Can be done using machine learning. So obviously, the higher the score, the more confident the user is good. But if the lower the score, that means the user is risky, and then you can start taking some actions around that. So you can start putting policies which say that if a user is risky, I want to step up the authentication. If they're trying to upload a file, I want to step up the authentication because I want to make sure it is who they are and it's not a compromised credential, for example. So this is examples. Again, I give you some examples of insider threats and how you can address that using machine learning. The last part of this presentation is on external threats, right? What about hackers? What about malicious external parties who are coming for your data? So early on in my presentation, I talked about how cloud is becoming more and more the vector through which threats are being sent, right? So all the way, when you look at a typical threat campaign, there are many stages to the threat campaign. There's a reconnaissance, there's a weaponize, there's a delivery, exploit, install, callback, and persist, right? These are all stages of a typical malware attack, right? And today what we're finding that each one of these stages that I show here is using the cloud as a way to expose their data, right? So for example, you can use reconnaissance by using cloud service APIs, right? So if your cloud is misconfigured, you can use that information to gain knowledge about an organization. We are finding cloud phishing, as I talked about, very, very common. You get phishing email and the link says it's hosted in OneDrive, right? So very common. Similarly, we're also finding that hackers are using Facebook, YouTube, Twitter, Slack as applications through which they send data back, right? So for example, if they are exfiltrating sensitive data from somebody's endpoint, what they're doing is they're using a common cloud application to exfiltrate the data out. So overall, more and more of the malware kill chain is using the cloud as a vehicle to perform their activities. So along those lines, what can artificial intelligence and machine learning do, right? First thing is when you look at malware, right? Malware can come in many forms. PE stands for portable executable. So these are executable files, right? So many times what you will do is you will see phishing campaigns where you have an executable file that is as an attachment, right? Normally, the best way to detect these threats today is to do a virus scan, which is not very effective, but still quite effective. It will not catch any zero-day threats and so on. The next best thing you can do is sandbox. But as you know, sandbox is not real time, right? With sandbox, what you have to do is you have to detonate the file, you have to observe the behavior. And so it takes in the order of minutes to detect malware. But what we can do with machine learning, again, supervised machine learning, because we have millions of malware samples, we can train the machine to automatically detect malware, right? So what we are finding is by using machine learning, we can get 99% accuracy of detecting malware. And you can do it in real time as opposed to using sandboxing, which is not real time, right? Similarly, a more common way of malware is MS Office files, right? So people use Excel spreadsheets or Office documents or even PDF documents, right? And they have macros in them, and the macros are, once you click on the file and the macros execute, they take advantage of some vulnerabilities. For example, if your endpoint is not patched, they take advantage of that and take over your system. So again, that is a good example of how artificial intelligence and machine learning, again, because we have millions of samples of Office malware, we can train a machine learning model so that when a new Office file comes, we present it to the model and it gives a decision, is this a malware, not a malware, or maybe suspicious, right? And we can take some action, right? So very, very good use of artificial intelligence and machine learning for detecting malware. Now let's move to the right-hand side here. What is DGA? DGA stands for Domain Generation Algorithm. So many malware sites, right, they automatically generate domain names, right? The domain names are not fixed. So when you look at security solutions like secure web gateways, they have a list of domains they will block. They say it's a risky domain, right? But if these domains are automatically generated, those lists cannot keep up because these happen like in the order of seconds, right? But automatically generated domain names are different from human generated domain names. And again, that is an example of how AI and ML can help detect, given a domain name, it can tell you if this domain name was generated by a human or if it was generated by a machine, right? And if you know that a domain name was generated by a machine, you can take some action against that because you may not want to allow that, right? So again, a very good use of machine learning where the machine is able to detect, is this a pattern that a human generates or a machine is generated? Similarly, URL grouping as well. So again, a common way in which, if you look at URLs, especially some of these malicious URLs, they're very long, right? And they will have a lot of characters that are not common, right? And so how do you then keep up with threats where these URLs are constantly changing? These are like polymorphic attacks, right? You keep changing. And that is, again, a good use case for machine learning, where you can use machine learning to automatically detect, is this URL a malicious URL, or is this a benign URL? Again, so at a very high level, there are different techniques that can be used to detect external threats using machine learning and artificial intelligence. And a modern security solution would definitely address that, right? So what I've done so far, and the last one that I will talk about is web content categorization. So again, very common use case for security solutions is to categorize websites to figure out, is this website a shopping website, is somebody going to an educational website, and so on, right? So many times what happens is there are new domains that come up and the website may not be categorized. Another good example of AI and ML is to use when the content comes back, you run it through ML algorithm. In this particular case, the universal sentence encoder, and that can detect what type, is this a dating site, is this a gambling site, or is this site talking about weapons and violence, and so on, right? And we have this covered for 16 languages, most popular languages in the world. And again, so a good example of how AI and ML can be used for dynamically delivering security. Otherwise, the only way to get categorization is to have static list, right? You put a database that says this URL is a dating site, this URL is a gambling site, and so on. Whereas here, you're automatically looking at the content that's coming back from the website and telling that what type of site it is, right? Another very good use case for AI and ML. So I hope, I mean, in the presentation, I've given you different examples of artificial intelligence and machine learning being used for data protection and threat protection. So I just want to summarize my talk here. Again, going back to the challenges that we are all facing, the future security architecture, if you were to ask me, consists of some important aspects, right? We talked about the secure access cloud, where you are monitoring users going to web, SaaS, IaaS, PaaS, and data centers and applying policies. But at the same time, endpoint is again a very important aspect of your threat protection. So you want to make sure that you have a modern endpoint solution. Identity is another important part. More and more organizations are adopting single sign-on. So that is another important component of your security program. And finally, having a security event management system that is able to take events out of all these different security solutions, correlate them, and give you some response actions is also important. So overall, when you look at a future security architecture, these are the 4 big building blocks, right, that you should consider. Now, all of these should not act in isolation. So one of the things that we at Netskope have done is also created a free tool called Cloud Threat Exchange. So with the Cloud Threat Exchange, what you can do is you can share threat information between these different solutions. So we have given some examples of like EDR vendors like CrowdStrike, Carbon Black, SentinelOne, email vendors like Mimecast, and then cloud vendors like Microsoft, and then ServiceNow. And then another common way in which threat information is being shared in the government and financial institutions is Stix and Taxi. So we have created a free tool. Netskope has created a free tool called Cloud Threat Exchange that is available in Docker Hub. If you go to Docker Hub and look for Netskope, you will find Cloud Threat Exchange. And you can use Cloud Threat Exchange to exchange threat information between all these solutions and Netskope, right? And if you have some other solution, that can be plugged in as well. It's an open architecture. It's a free tool that is available to help with your cloud, with your threat protection, right? I just want to finally end the talk by telling that when you look at the security cloud, another important aspect of the security cloud is also the points of presence. You want to make sure that your users are as close to where the security is delivered. For example, we are the only security vendor in Latin America. We have 4 presence in Latin America, including Bogota, Santiago, Buenos Aires, and Sao Paulo. And so you can be assured that your traffic is handled locally. And also what is more important is not only that your security is handled locally, but also the peering, being able to directly connect you to all these important providers like Microsoft, Amazon, Box in our own network is also important. So overall, when you look at cloud security, it's very important not only on what controls are provided, but also where they are deployed and how efficient they are, right? The closer the cloud security services to your users, the better performance and user experience they get. So overall, that's another important aspect to consider as well. So that's all I had to present. Gracias. I'm available now for any questions that you may have.
Well, great. Thank you, Krishna. That was really, really good. Yeah, and I have a lot of comments and a couple of questions. Let's begin with my comments here. And I don't know, can you hear me okay?
Yeah, I can hear you.
Okay, good. You started the whole project, the whole presentation with Modernize security controls. And at the end, you showed the diagram with the endpoint. And then, single sign-on, identity, and all that stuff. So with COVID and everything, it has accelerated the adoption of all this digital transformation. I mean, like 3-5 years, you have to do it now. What has been your experience with clients now having to update or accelerate their adoption of these new controls for security?
Yeah, that's a great question. Thank you, Edgar. So yeah, overall, what we are observing is, especially because of the COVID pandemic, right? More and more organizations are adopting cloud applications. So the number of cloud applications is increasing. And also, they want to make sure that the identity, which is the first door, right? You need to enter, the first door is identity. So adopting single sign-on, right? With multi-factor authentication is becoming more and more common. And what they're trying to avoid is they want to keep the user experience as effective as possible, right? So you do not want to depend on VPNs. You don't want your users to open VPNs to go back to on-premises for identity or for security. You want direct internet access. And then also, as I try to point out, you not only want the identity allows you to open the door to go to OneDrive or to go to Box or Dropbox, but once you get into the application, the concept of continuous compliance, that is, every activity of the user is being monitored so that you make sure that they're compliant with the policy.
Okay. No, perfect. Yeah, compliance is extremely important, and it makes you have to actually go ahead and update your policies as well. That was a conversation we were having in our weekly show this weekend. AI ML. Everyone keeps talking about AI ML. Throwing it for the past 5 years. This is the first time that I see a really good explanation of how it is being used, especially ML for identifying screenshots. Mm-hmm. Because that was a conversation we had a couple of weeks ago where someone says, well, how do you stop someone from sharing a screenshot of proprietary information? You can't. So now with ML and AI, you can actually do that.
Absolutely, yeah. And the good part is you can do it in real time. So by building, the advantage of AI and ML is these algorithms are running in modern CPUs. They run really fast. So once building the model takes time, but you don't build the model every day. You build the model once in a while, you update the models. But once you put the model in production, then what happens is the decision can be taken very quickly. And as you saw, where we are very excited is we can bring that AI and ML to the customers.
Yes. And that was my next question. So basically, you already done all the learning for the solution. Now it's up to the client to take whatever additional, specific to them to actually teach the ML. Okay, exactly. That's perfect. And then the last slide you showed, he can mouth, perfect. The last slide you showed about the connected network for cloud security. Mm-hmm. So is that the same for LATAM? I mean, do you just have the presence, or do you also implementing all the security controls that you have deployed all over the place?
Okay, that's a great question. So there are two architectures when you look at delivering cloud security, right? There's an architecture called the front door architecture because, as you know, many countries have different languages, right? And so depending on where your IP address is, the content that Google serves, like for example, if I come from Colombia, I'm going to get a Spanish version of the Google page, whereas if I come from US, I'll get the English version, right? And the way they do that is using the IP address and identifying where the IP address is. So many cloud security providers, what they do is they have a front door so that they get an IP address. So they get the address from the local country, but all the security processing is done in Miami or somewhere else, right? And that is not efficient because you're moving all the data outside through expensive network connections. Now, what we have done at Netskope is all the data centers, you saw 4 of them in LATAM, right? All of them are full data centers where it's not the front door. It is also where all the services. So all the AI ML I talked about today is running in Bogota as we speak today.
Oh,
so our
nice.
customers who are uploading files, these algorithms are running on them as we speak in those data centers. So all the data centers are fully functional. All functions are available. And I think that the other important point that I made was we also peer with Microsoft, Amazon, all the major providers. The reason why that is important is once you finish doing the security policy enforcement, right? If you send the traffic back to the internet, you're going to go through the local highway, local roads. Whereas if you have a peered connection, that is like the fast highway to your service. So the overall experience of the users when they go through a peered network is very high.
Yeah, that's fantastic. Yeah, the experience is fantastic. Perfect. Well, Krishna, I really, really appreciate it. I know it's very early. You're on the West Coast, correct?
Yes, that's okay.
Yes.
I had my coffee. I had the good Colombian coffee.
Oh, perfect. That's the best.
I enjoy coffee.
Well, I really appreciate you being here with us. It was a really good presentation. I know that we're going to be dissecting this, and I hope that everyone enjoyed having this opportunity of speaking with the founder of Netskope. It's not an opportunity we get every single day of our lives, so I really appreciate you being with us, Krishna. Thank you so much.
Thank you. Gracias.
Gracias a Krishna Narayanaswamy de Estados Unidos, fundador y CEO de Netskope. De verdad, increíble conocer todos estos temas, Edgar. De verdad, es un placer haberlo tenido abriendo este gran evento de ciberseguridad de Tactical Edge de 5 días. Esta es la calidad de presentaciones que nosotros vamos a tener durante estas jornadas, Edgar.